Good afternoon. My name is Stanislav Gulak. Before I start with my presentation, let me say just the main idea of my presentation. Digital model is a model of the terrain. The terrain model is a basic model for most of the engineers when they design any on-surface structures and any engineering works. That's idea number one. And second point, the technologies that I use, that I'm going to talk about in my presentation, are better suited for real estate development when you build several buildings on one plot. We started drone designing in 2004. In 2008 we became a part of Kalashnikov concern. This is our geographical outreach. These are the regions where we have our geo-survey departments that provide geo-monitoring on a regular basis. And you can see also the regional offices. Geography is very diverse, so we know the specificities of this or that environment, and we can adapt our drones accordingly. Climatic conditions, flight duration, flight distance, everything is adaptable. Heat vision is one of the main tools that we use, but in BIM application, the most useful tool is photography, and also laser scanning, so airborne laser scanning that I'm going to talk about later. This slide shows the pictures that you probably have seen many times, and you know very well how to integrate BIM and GIS workflows. Information modeling, according to our view, is impossible without knowing your terrain. The data that are accumulated in GIS, that's the data that are accumulated in GIS, and at the interface of these two systems, a new concept appears: CITSI, information modeling, SIM. That's a set of information data in 3D, in 3 dimensions. This is the interlink of GIS and with BIM data level of detail. Landscape, buildings, structures, the entire space, infrastructure, everything is taken into account. There are some successful cases where terrain wasn't included in the design, but it's pointless or even impossible to implement SIM without terrain data. Already at a city district level, you need a 3D terrain model, not to mention a more complex sites. Without this information, infrastructure, roads will not be designed correctly, which will affect the life cycle of an asset. Terrain is important not just for geology or geodesic studies, but also for environmental impact studies and other studies as well. It affects the foundation of a building and other processes. So to gather this terrain information, you can use 2 available technologies: aerial photography and aerial laser scanning. We provide both. Classical photography, aerial photography, using the drones, unmanned aerial aircraft, has sped up this geo-survey process. It provides digital terrain model, but it also helps you, allows you to build a 3D scene based on from the photos with the density that exceeds classic geodesic models by the factor of 20. And point cloud, you can separate different points in the point cloud, and based on separate points you build a digital model, digital relief, digital terrain model that is used in GIS system. It's very simple and it doesn't require much computing power to process it. Design and current status control. It's better to use TIN model, triangular integrative network, that uses triangles that do not touch each other. This model consists of the same points, the same as a digital terrain model, but it's lighter and more easily can be more easily edited or changed. If you noticed, all previous slides had quantity of data, such as point density, up to 30 points per square meter. Compared with classical geodesic survey, where the distance between the points is from 5 to 15 meters. Using these digital models, you can restore classical horizontal vectors and other information, which helps you to improve your design procedure and you get better understanding of the terrain. And then you can use these models to provide better estimations. This area is 3 square kilometers. Field works were done in 2 days. 1 day was for data processing.
The accuracy of calculations meets guidelines, meets normatives. The orthophoto maps can be used to control construction activities within the construction process, used to understand land activities, land survey activities, and also control other parameters, including security. The aerial photography with further treatment is a tool to control construction activities and a way to monitor progress. We've also started using the technology of laser scanning. We install the modern cutting-edge technologies, and the results we get is a cloud of dots, is a dot cloud that describes the relief, the landscape, and the sites. The key difference here, from the aerial photography, you see the red dots from the aerial photo and the gray dots from the laser aerial scanning. So the aerial photography dot cloud forms the key structures, so we see only the surface in this case, while laser scanning can go deeper. For laser scanners, we are using cutting-edge technologies. Older technologies are quite frequently met in the Russian market, and this is the example of their results. They are not that inferior to aerial photography. To the left you can see examples in the slide. In this slide you can see in the result of the aerial laser scanning, you see that it's colored because the photo was combined, the combination of loads can be different. We can use multispectral photography and also other solutions, including thermal cameras, to get more information for designers. Laser scanning does not depend on climatic conditions. It can be handled, it can be made, it can be done at night time. The results we get from the laser scanning is drilled down to 5 centimeters, which is 3 times higher than the standard, while for aerial photography the average number of dots is 250 to 300, so we get results that are more sustainable in comparison with geodesy survey. This is a ready-made tool for designers to raise accuracy, and it also provides a detailed map on landscape and facilities. The digital model we get can be provided in a limited time, and it can be transferred, it can be treated in 3 modes using regular schemes, regular approaches, and the TIM model. For your understanding, I can show you a brief video. So that's it. Thank you for your attention.